All right, so as we move into 7.3 part 2, we're just going to finish up this last page. And we worked yesterday on scale factors, right? We talked a lot about what a polygon was, what a closed shape was, what a vertex was, what proportional meant. And we determined factors. I do want to just point out something. I noticed something. No one saw this, but I saw this morning when I was looking at the notes again. This be consistent. This little box is a little bit too consistent for your notes. So you do have to change something if you have your notes there. I don't know if you guys noticed. Is it frozen still? Sorry, it's frozen. I don't know if you guys noticed in this little box there, these two are exactly the same. So they're exactly the same. One of them should say, keep the larger polygon on top for all of your work, or keep the smaller. This should be smaller. So please change that, because that doesn't make sense if that's not like that. So keep the smaller polygon on top of the fraction for all of your work. One or the other is fine. You'll get the exact same scale factor or the same ratio as long as you be consistent, okay? So what I've taught you is that you always do the scale diagram on top. That will give you the proper scale factor, and that's what you should do. But if you're not sure, if you're just given two shapes, you're not sure which one's the original, then just do the larger measurement on top, the smaller on the bottom. And do that for all of them, okay? Or the other way around, do the smaller one on top, the large one on the bottom. It doesn't really matter. Just be consistent. All right, so popping back to the last part of this lesson here. So this last example that's on your sheet there says find the length of ZY, set up equal ratios. So there's a little hint. This is started for you here in the notes. This is what equal ratios are. So let's just take a look over here at the diagram. And I have two trapezoids here. And it is pretty obvious that WX, that this side of 1.8 centimeters, is corresponding with ST. You guys see that? So those are two sides that are the same, or the corresponding sides in each figure. Okay, they're not the same length, but they are the same in a sense that they are corresponding to each other. Okay, they're in the same position relative to all the other aspects of the figure, if you want to put it that way. So what they suggest is doing this. WX, that's the length of WX, divided by ST, would have to equal this unknown length of ZY over this known length of UV, okay, or VU. So we're given these three things, and I'm asked to solve for this one by setting up a proportion. So really easy thing to do. So let's try that. You show your work here, so 1.8 divided by 3, and it doesn't matter if there's a decimal in this ratio. It's not a simplified final fraction answer here. We're just using this equation. So 1.8 divided by 3 equals ZY. We don't know what that is, so let's just leave it as ZY. And on the bottom here, the value is 2. Okay. So when you get to this point, do you know how to solve for ZY? What's your ideas? Yeah.
You would divide 1.8 divided by 3.
Yeah.
And then you times whatever that is times 2.
Okay. So 1.8 divided by 3 times 2. Okay. That is going to give you the right answer as well. Perfect. One of the things that students are taught when they're younger is this, in order to solve for some unknown variable in a proportion, you cross multiply and divide. Have you heard that phrase? Okay. So that's the one that my students coming up from elementary always kind of say, oh, cross multiply and divide. So yeah, that's awesome. So that in that way, when you have just two fractions, okay, equal to each other, and that's all you have, you can always multiply the numbers across the equal sign, okay? Or you can divide numbers as well across the equal sign. So you can move them from the top over here to the bottom over here, or from the bottom over here to the top over there. Which means that when we cross multiply in this fashion, that's going to give us 2 times 1.8, and then this is still divided by 3. And I'm going to leave that 3 there because now I've isolated, or got all by itself, my missing side. So this is how you find the value of the missing side, by doing that. So we cross multiply. And sometimes if you're missing values on the bottom, you also have to divide some things off, and it goes across the equal sign like this, okay? And for those of you that know how to manipulate equations, solve equations, if you had something like this, I'll just put it over here. If you had something like, 2 over 3 equals x over 5, that looks very similar, doesn't it? Well, in order to get x by itself, you use opposite operations to get rid of all the things that's affecting x. So because x is being divided by 5, in order to eliminate that 5 from this side of the equation, you would multiply by 5. And what you do to one side of an equation, you always do to the other. So this is really the same as cross multiplying, but we don't draw any arrows and you don't think of it as going across the equal sign. But you see, that's the exact same thing. And that's what you would start to think of in high school here, is that, hey, I'm going to multiply both sides by 2 here to eliminate this 2 on the bottom, because that's now a 2 over 2 is just divides out to be 1. Okay? So think of it as cross multiplying and dividing when you have two simple ratios like that equal to each other, or use those opposite operations to solve for the unknown part in the equation. Yeah, question?
I have a question.
Mm-hmm.
Did you do 1.8 divided by 3?
Yep.
And then I think 0.6?
Yep. The order in which you do those doesn't matter. Yeah, because remember, this is multiplication and division. So in BEDMAS, they're really equal to each other. So it doesn't matter if you do 2 times 8 first and then divide by 3, or if you could do 2 divided by 3 times 1.8. You could do 1.8 divided by 3 times 2. The order of those doesn't really matter. You'll get the exact same answer.
If you get 0.6, that'll be the scale factor, right?
Yes, so the scale factor comes from, now it doesn't, we don't know which one's the original, right? But if you use the big one, if this is the original and this is the scale diagram, let's say, then you would take this 3 and you would divide it by 1.8, and that's your scale factor.
So if you did multiply the scale factor by 2, by 2, can you do that to get, like...
Yeah, the other way you could do this, okay. So, yes, this is not the only method to solve for zy. So what you're suggesting is what we learned earlier, which is totally fine. I'll just outline that real quick. If you found the scale factor by dividing these two to get the scale factor, then what you could do is see, here's the tricky part though. You can't multiply 2 by the scale factor necessarily, because you're going back to the original. So you'd have to take this 2 divided by the scale factor. So whether you multiply or divide by the scale factor then becomes a little tricky. You don't know which one to do, and you could do the wrong one. Now, if you looked at your answers afterwards in order for it to make sense, then yeah, you wouldn't probably make much of a mistake, because obviously, this number is smaller than this one, so this number here should be smaller than this one. So then you've multiplied or divided correctly. But I would suggest this ratio is the most straightforward way to go. So what is that answer, by the way? Anybody figure that out on your calculator? 2 times 1.8 divided by 3. You shout it out. Anybody get it? 1.2, that's right. And of course, because this is a question that has units, our final answer should be written in centimeters as well. So please don't forget your units as well. If the question has units, and some questions don't, they just have, the lengths in no units. Some don't give units. But if they give units, you'll have to make sure your answer's in units as well. Okay? All right. Something else I need to draw your attention to as well is in all these examples so far, the similar shapes have all been the same orientation. So they've all been facing the same way. Okay? So notice that we have this pointy part facing right on the ground. We have, in the pentagon here, the pointy part is kind of on top or whatever, right? So they're all facing the same way. The trapezoid sits the same way. Please note that shapes can be similar even if they are not oriented the same way. For example, these two shapes, they're hand-drawn, but if I tell you they're similar, you should be able to identify the proper corresponding sides. All right? So this is something that you're going to have to work on. You can't just say, oh, this side is on the left and this side is on the left, so they must be similar. No, can't do that. What you have to understand is that one of these sides is obviously moved around, it's flipped around, and it's actually flipped this way on the page as well, kind of thing. So this would be one of the more challenging kind of ones to identify. If this is side A, okay, then 1, 2, or 3, which side goes with side A?
2.
2 is correct. So that one's good. That's maybe easy to see. But what you want to do is you want to say, okay, I've got the 90-degree angle, then I've got A, then I've got the larger angle of the two. So 90A larger. Okay, so 90 and then one of these two numbers, and which one's the larger one? Again, tough to see because of my hand drawn, but this is the larger one. This is a longer side here. So 90, this one, and the larger angle. So you can do something like that, right? Because relative to the other parts of the triangles, you should have the same sort of situation. So yeah, 2 is correct. And if I went to B here, that one should be pretty easy on a right triangle, right? Because it's the hypotenuse on this triangle. It's opposite of the 90. So we know that 1 goes with B, right? So A goes with 2, and then obviously the other one. Here's another couple that I just grabbed off the internet here. So if we look at these ones, the first one is maybe a little tricky. There's no 90-degree angle there. So you'll have to use other means. Okay, so if this is, let's say this is A, and I've got 1, 2, 3, which number does A go with?
1.
Okay, so some people say 1, some people say 3. Anybody for 2? Anybody for 2? No votes for 2. Okay, so between 1 and 3. So here's the, this is an obtuse angle, looks like. It's greater than 90. That's the biggest angle here, okay? And then we have the smallest angle over here. So if you wanted to look at it this way, it's going to be largest angle, and then our side in question, and then the smallest. So largest, side, smallest. Here's largest, and here's the smallest. So guess what? A goes with 3, right? Because this order holds true here as well. And some of us are better, I would say, at visualizing things spatially than others. So if you're a visual type person, you can probably take a look at these shapes, and right away you would be able to do this kind of thing in your head. And for some, it's a little trickier. And I understand that we have both types of people in the room, and maybe you are very spatial, but this really confuses you. Spend some time thinking about this, and spend some time trying to move things around in your head. And I would also suggest take 2 similar shapes, like real shapes, so like one of these plentiful late slips here, and make a similar shape out of it. And I'll do that right now, just real quick. If I can find a pair of scissors. Oh, here's some over here. Okay. So what I'm going to do is I'm going to make a shape out of this, and I'm going to try not to make it, super difficult. But here's this shape here, and I'm going to try and make a similar shape over here. So I'm going to keep some of the same angles, but I am going to cut this at different places. Okay. All right. So real quickly, and you can do this as well. Okay, we're almost there. So here we go. We got two similar shapes here. Okay, and if you rotate these around on your paper, you can kind of follow the corresponding sides and angles. Okay, the 2 sides on top. Okay, now we've got a side on the top and a side on the side. Flip these around. Okay, flip this one around. Move it. Stuff like this. Do this kind of exercise on your paper with 2 similar shapes. Don't move. And you'll be able to practice that. One more thing I wanted to show you. This is another example right here. If you're given side lengths, they probably won't be equal like this. But again, start with one side that you know. This is the side in between the 90s. So here's the side in between the 90s. Those 2 are corresponding. The longer side beside one of the 90s is here. The longer side beside one of the 90s is here. So start to practice connecting those even when those shapes are spun around or flipped. Okay? All right, finish your 7.3 assignment for tomorrow. We'll see you later. Go.